What's going on, you math nerds? Welcome back to another episode. Here we're going to talk about simplifying negative exponents. Let's just go ahead and dig right into it. So it says, negative exponents are a way of expressing the opposite of repeated multiplication. Right? So we want to think about that. The opposite of repeated multiplication. So now what would the opposite of repeated multiplication be? Well, since the opposite of multiplication is division, we can think of a negative exponent as repeated division. Right? It's the opposite of that repeated multiplication, hence repeated division. Shown with a math symbol, a times b to the power of negative n equals a divided by b to the power of n. And let's go ahead and think about what that means, right? We have repeated multiplication on b, right? We have an exponent. That's what our exponent means, is repeated multiplication. And it's of negative n, right? So repeated negative n times. And normally when that's a positive, what that means is we have repeated multiplication. We're repeatedly multiplying. So now when we throw a negative on that, it's going to be the opposite of the multiplication. Right? So we're still going to repeat it, but it's going to be negative. Right? And so what is the negative of multiplication? Precisely division. Okay? And if we wanted, we could even expand this out and see how it's dividing by b times b, or b divided by b divided by b divided by b divided by b, all the way on n number of times. Okay? So conversely, oppositely, right? This can be used in reverse to simplify repeated division. Written a divided by b to the power of negative n equals a times b to the power of n. Right? So check that out. So here we went from something that was negative repeated multiplication to repeated division. Here we went from something that was repeated negative division to repeated multiplication. Right? And so aesthetically, the way this looks, you can just think of this negative as just having to switch sides over the fraction bar. Right? We have a negative up here. If we want to get rid of it, we're going to have to bring it to the bottom of that fraction. And likewise, when we're on the bottom, if we're going to apply a negative to it, we're going to have to bring b to the power of n up to the top. Okay, so let's go ahead and look at what this looks like in practice. Okay, so realize we have 2 times v to the power of negative 2. That 2 is not attached to v, right? That negative 2 exponent only applies to v and not 2. Right, so we have 2 times v to the power of negative 2 divided by 3 times v to the power of 3. And so what we want to do is we want to get rid of this negative exponent using our rule. And so we see this is going to flip over the fraction. Right? It's going to go from that repeated multiplication of a negative number to just repeated division. And so it's going to look like this. Now realize that only this has the negative. Only this is doing the flipping. Everything else, it's just staying in the same place. It doesn't move at all. Okay, so what had the negative exponent? It was the v to the power of negative 2 on top of the fraction. So it's going to go to the bottom of the fraction, to what we call our denominator. Just like that. Okay? That's the use of our new rule. That's the new rule that we are acquiring in this video. The ability to now deal with negative exponents. And we're going to elaborate on this as we go forward. But let's also go ahead and just take this all the way. Let's go ahead and simplify this and bring it on home to the final answer. So now there's 2 ways to go about this. I'm going to go about it the more thorough way at first. Yes, and of course thorough means longer. But realize I'm going to go about it the more thorough way first. You want to make sure you understand this way before you jump to the quicker way to do it. Alright, so what we're going to do is we're going to expand any exponent. What does that mean? Well, we're just going to turn our exponent into what it truly represents. So v to the power of 3 means we have v multiplied 3 times, repeatedly multiplying v 3 times. So we're then going to write v times v times v. right? This is like a condensed version of it. This is a really simple and easy way to express something that would otherwise take up a lot of space. So we're also going to do that with v to the power of 2. Right? V to the power of 2 means we have v times v. Right? V repeatedly multiplied 2 times. Okay, and now it's fully expanded. Now what we're going to do is we're going to go ahead and go back and condense this. It can feel a little redundant, right? Right? Expanding it just to then condense it back. But watch what's going to happen. So when we want to represent something as an exponent, what we're going to do is just count the number of times it's been multiplied. Right? Exponents mean repeated multiplication. So we're just going to see how many times that multiplication of v is repeated. So we have 1, 2, 3, 4, and 5. So we'll write v to the power of 5. And that's just a very shorthand way of saying, hey, I got 5 v's, multiplying all of them together. Okay. Now, the shortcut method, right? And this is for the more advanced student, the student who has things like this kind of ingrained a little bit. They're going to see this and realize, oh, this means I have 3 v's, and oh, this means I have 2 v's. Thus, right? Therefore, I have 3 v's and 2 v's all being multiplied, which is going to give me a total of 5 v's. We can actually just add those numbers because we realize they're all just representing repeated multiplication of the same thing. This one says do it 3 times, this one says do it 2 times. So in total, we're doing it 5 times. Okay? Alright, next example. So, we want to go ahead and take care of the negative. We want to look for those negative exponents, and it's not that we have to take care of those first, right? If you see x squared and you see x to the power of 4 and you say to yourself, oh, some of these are going to cancel, I know that. You can go ahead and do that first. That's fine and dandy. That's completely okay. But me, the order I like to do it in, the solve preference, I like to take care of the negative first. Okay? But that may not be you. And if that's not you and you don't do it best that way, of course, don't. Okay? So I'm first going to take care of that negative. Remember, that negative just represents repeated negative multiplication. What's the negative of multiplication? What's the opposite of multiplication? That's just division. So that's going to become, on the bottom, on the denominator, x to the power of 4. Let's write that a little bit more neatly. X to the power of 4. And then everything else is just going to go down there. Okay. Now let's also go ahead and keep this organized by bringing our coefficients to the front. Remember, the coefficient is that number, that constant, right? 2, pi, 6, 24, 187. That number that multiplies a variable. That's what a coefficient is. So let's go ahead and bring both those to the front. We're just doing a little bit of rewriting in this step. Right, x to the power of 4 times x to the power of 4. Cool. Now we're going to go ahead and just to be clear, we're going to draw a dotted line here to separate those two problems. Now we're going to go ahead and combine these. Okay? I'm going to skip this step. Now, if this makes you uncomfortable skipping this step, don't skip it. Right? Keep on doing it. Keep on doing it until it's to the point where you're like, this step is a pain in my butt because it takes so much time. I know what it's going to be. I got it down pat. Once you're in that situation where you feel like that, that's when you want to skip that step. Okay? So I know that repeatedly multiplying x 4 times and repeatedly multiplying x another 4 times, I'm just repeatedly multiplying it 8 times. Okay? And likewise, if I have it repeatedly multiplied 2 times on top and 8 times on bottom, well, that's going to only leave me left with 6 repeatedly multiplied x's. Okay, because for each time I multiply by this on the top, I can take away one that's multiplied on the bottom. They cancel out in a 1-to-1 ratio because they equal 1 when divided by each other. Okay, so that's going to leave me with 6 repeatedly multiplied x's on the bottom, or 4 divided by 3 times x to the power of 6. Okay. Ooh, good old knuckle crack. Let's go into the next example. Right? We are ready for it. The knuckles are cracked. They are fresh. Let's go ahead and knock this baby out. So, again, I want to take care of the negatives. And actually, before I take care of the negatives, I'm going to go ahead and take care of v to the power of 0. And I'm going to do that because it's actually the easiest thing to take care of. It's going to make this less visually cluttered, and it's also one of the easiest steps to do. So now we want to ask ourselves, right, and this is actually really logically simple, we have v multiplied 0 times. V multiplied 0 times. How many v's am I going to have? Right? Don't overthink this. How many v's am I going to have? I'm going to have none of them. None of them have been multiplied, so we can just go ahead and take that out of there. Okay? Now, a lot of the times we're going to say that equals negative, or that equals 1. Right? Anything to the power of 0 equals 1. And what we mean when we say that is, yes, absolutely, we multiplied it 0 times. Right? But multiplying something 0 times doesn't leave us with 0, it just leaves us with a neutral number. A neutral number that can be any other number, aka 1. Right? That place-holding 1. Right? 1 can multiply by anything, and it's good. It's the identity number. So when we have something raised to the power of 0, we just take out all of that something because we didn't multiply by any of it, and we're left with just a 1. Okay? That's a big concept. That doesn't totally make sense yet. That's okay. But realize that's the logic, and that's the reasoning behind it. Okay? So just like that. And the v to the power of 0, we just got rid of it. Right? We're not multiplying it by anything. Let's just get it out of there. Now let's go ahead and take care of our negatives. So I'm going to do all my negatives at one time. So we want to keep track of this. So this negative is going to have the u flip to the other side of the fraction. Just like this negative is going to have this u, right? U to the power of negative 2 flip to that side of the fraction. So let me go ahead and do that. Okay, first set up my coefficients right there to keep this nice and ordered. Now this u is going to go to the top. So up here, I'm going to write u to the power of 2. Now, this u is going to go to the bottom. So I'm going to write u to the power of 1. And realize, right, u to the power of 1 is just the same as u. U's been multiplied only one time. We have 1u. Alright? And then rewriting everything else. V to the power of 2. And then on the bottom we have v to the power of 3 times 3 times u to the power of 3. Alright? Now, let's go ahead. We're going to do, again, 2 steps at once. I know it's kind of big, but that's okay. It's going to save us a little bit of space, and we can definitely do this. We want to bring our coefficients to the front. So first things first, let's get all these numbers out of there and clean it up. So we only have a 2 on top, but on bottom we have a 3 and a 3. And remember, all these things are multiplying. Right? When there's no symbol or when there's a dot between it, that means multiplication. So let's do 3 times 3, and then write that number at the front. Right, which is 9. Okay. Now we can go ahead and start canceling out and combining any of these other variables. Okay, so I see that I have 2u being multiplied on top and 1u along with 3 other u's. Don't forget there's this one, but then there's also these, right? We did it once and then we do it 3 more times for a total of 4 u's multiplied. Right, so we have 2 u's on top and 4 on bottom. That's going to leave us with 2 on bottom. Those 2 on the top are going to cancel with 2 of the ones on the bottom. Right, if we started with 4 on the bottom and we take out 2 of them, that leaves us with 2u to the power of 2. Okay, and let's take that same kind of reasoning with these v's. We have 2 of them on top and 3 of them on bottom. 2 are going to cancel with 2 of the ones from 3. So 2 from 3 is just going to leave us with 1. So v to the power of 1, right? Those 2 canceled out with 2 from there. And just like that, that's actually our answer. Oh, and this is my bad, but we actually want to get in the habit of boxing in our answers as we go. Okay? Now on to the toughie. Now on to the question that is most likely to be a quiz question, right? Because it's exercising all those skills. So what is the perimeter of a rectangle with dimensions 6 times x to the power of 2 times y to the power of negative 1, all divided by y times x to the power of 3, for width x to the power of 2 times y to the power of negative 1, all divided by y times x to the power of 3 for length. Okay, so this is a tough problem. Don't kid yourself, right? A lot of math skills being used here. If you don't know one of those math skills, it can kind of hurt you in here, right? So as hard as this problem is, also realize in that this is what's going to make you better, right? It's these problems that hit all those skills, that exercise all those parts of your brain, all those muscles at once, that are going to make you strong. Okay, so let's go ahead and get into it. So what are they asking for? They're asking for the perimeter. The perimeter of some kind of rectangle. Now, I know the perimeter of a rectangle is going to be the length plus the width plus the length plus the width. How do I know that? Because perimeter is the total distance around the outside of a shape. Right, so that total distance would be 1 part length, 1 part width, 1 part length, and another part width. Now, what did they say is the dimension for each one, the width and the length? Well, they said the width is this right here, so let me go ahead and plug that in. So 6x squared times y to the negative 1 times y times x to the power of 3. Plus, that's where my L goes, plus the same kind of width, so let's also plug that in there. Do both of them at one time. Alright, just go ahead and substitute all those in. Okay? Now what else do they give us? They give us the length. So let's go ahead and do that same thing and put that length into there. That length's going to be x squared times y to the negative 1 divided by y times x to the power of 3. Okay, and bring down everything else that we already plugged in. And I have another L. Remember, that's length, right? It's going to be the same thing. X squared times y to the negative 1 divided by y times x to the power of 3. Then bring down that last part. 6x squared times y to the negative 1 divided by y times x to the power of 3. Cool. Now, this is where it gets crazy, right? This is where it really gets juicy. We need to remember what our 6th grade teacher taught us. What our 6th grade teacher taught us about fractions. What did he or she teach us? He or she taught us that in order to add fractions, right? That's what we're doing here. We're adding fractions. We need to have the same base. Right? We need those same bases. And lo and behold, look at what we got. It's almost like it was planned. Hint, hint. Wink, wink. Okay. So when we add these fractions, because they all have the same base, we're just going to combine the bases and then add what's on top. So we have x squared times y to the negative 1 plus 6x squared times y to the negative 1 plus x squared times y to the negative 1 plus 6x squared times y to the negative 1. Oh dear Lord, it is like 9 o'clock. The building is empty, I'm the only one here, and I think I'm hearing voices. Okay, time to talk louder so I don't hear the voices in my head. So, now let's go ahead and see what else we can do. What else we can do to this? What else can we do to this? That's when we notice something special about what's being added. Something that's in common, something that is like. What is like about this? The terms. Right? What is a like term? A like term is anything with the same variables raised to the same exponent. Right? And let's check this out. So we have x squared and a y to the negative 1. We have a x squared and y to the negative 1. We have a x squared and y to the negative 1 and an x squared and y to the negative 1. Those are all the same term. Same variables raised to the same power. So what's that going to mean? That means we can go ahead and add the coefficients. We can combine our like terms and just combine the coefficients. So I know this coefficient is in here, but when we don't see a coefficient, that means we have just one of this, right? It's implied. So we have 1 of this, plus 6 of these, brings us to 7, plus 1 of these brings us to 8, plus 6 more is going to bring us to 14. So we're going to have 14 of these x squared times y to the negative 1 terms, all divided by y times x to the power of 3. Okay, just like that. Now time to use these new skills we picked up, right? Holy moly, right? So take a second to realize all the steps that we went through, right? All this math that's going on underneath this just to get us so we can now use that skill that we learned, right? Look at all the layers here. Realize the more the layers, the stronger you get. Okay? So let's go ahead and use our new exponent rules to simplify this. So I'm first going to go ahead and take this y to the negative 1, bring it on down to the bottom. Okay, and I took that y to the negative 1, put it right there. There's a y, and then there's x to the power of 3. Now let's go ahead and combine and simplify and cancel out any terms we may need to. So I have 2 x's on top and 3 x's on the bottom. We can go ahead and cancel those. So we have just 1 x on the bottom. And then we have 2 y's on the bottom. Well, I can make that a little prettier, make it a little more condensed, and write y to the power of 2. And just like that, we have our answer.